Hey scholars, it's Miss Lockhart here. I'm glad you were able to get started for today. Congratulations, you have reached the last day of the regular school year. Well, if you're A day, you have one more day left, but it will be your last math class if you have a 70 or higher, so congratulations to you all. Reach out to me by email if you have any questions. Make sure you use your Riverside email to complete your IP. The last day of the quarter is Thursday, and so if you have a 70% or higher, you are done. If not, you need to use the next week or so to get some work turned in. Okay, it's a secret, so don't tell anyone that I'm giving you a whole extra week to get your missing assignments in. Okay, it's a secret. Bonus project, that is due Friday at midnight, and you must submit it through the Google form. In addition to Stacy K and LJ, Hanaya, Thomas, Chris, Marcus, and I just got another one in my email actually. Let me open that up to see who it was from. Sakai. So awesome job to all of you who submitted your extra credit assignment, and I know that Kaylee is working hard on getting hers completed. So many of you have taken advantage of this 20 points extra credit, and it will definitely boost your grade. So my celebration, and I'm pretty sure it matches the rest of your celebrations, is that we are finally done. Okay, we have persevered and we have really just taken this whole time in our lives and we've made it work for ourselves. And so to come to the end is just a great thing and a big celebration. So actually today our code word is done. Okay, so that is our code word for today. Done. Okay, so if you're ready, that means you already know how to solve and graph a quadratic. If you have problems with that, please go back to haiku and look at the appropriate lessons for those things. Make sure you have a piece of paper out and a pencil so that you can do the practice problems that I have here today. So here's a little history of quadratics that I haven't shared before, so I wanted to share now. The ancient Babylonians and Egyptians were the first civilizations to explore the idea of quadratics. Okay, this all started in Africa. Okay, their investigations mostly centered on the maximization of the area of rectangular buildings and plots of land. So if I buy this plot of land, how much can I put on it? If I buy this rectangular building, how much can I fill it up with? Okay, because symbolic algebra wasn't invented until much later, they used geometric modeling to solve these types of problems. Okay, so for example, we have a garden problem. It says Miss Hoffman is going to start a quarantine garden. She got 52 feet of planking to build a raised bed. What is the largest area garden she can build? So first things first, we need to go ahead and label in our word problem the important facts. So 52 feet is our perimeter. And then it's asking us what is the largest area. Okay, so that is very important. So those two things are what we're going to annotate in our word problem. So here we don't have any equation to write out for our length because our word problem didn't give it to us. So we'll just label this L. And our width is always just W as usual. So because we were given the perimeter, we can also note that the perimeter equation is 2L plus 2W. Okay? So we're going to start with that. We were given our perimeter, which is 52, so we can plug that in for P. Equals 2L plus 2W. Okay, this is where we're going to get our length equation from. So we have to solve for L by subtracting 2W from both sides. So we can't combine 2w and 52 because they are not like terms. 52 does not have a w. So we write them as two separate terms, okay, which is equal to 2l because that's canceled. Last step is to divide by 2. So our length equation is going to be negative 2w plus 52 all divided by 2. Well, we can simplify this and it'll give us negative 2, If we simplify it, we can actually divide negative 2 and 2 and we get just w. So negative w. And then 52 divided by 2 is 26. So this is our length equation. Negative w plus 26. So now we can work on finding the area that we were asked about in the problem. So area does equal length times width still. Our length is negative w plus 26 times w. And we can use the distributive property to find our quadratic equation. So it's negative w squared plus 26w. Usually we do have 3 terms. This time we don't. That's okay. As long as we have a squared term, it's a quadratic. So let's look at this negative symbol here. This means that we're going to have a downward, like a frown shaped parabola, and the maximum is our vertex. Okay, so this is where that word largest comes in. Okay, so to find my vertex, because we're looking for the largest or the maximum, all we have to do now is use our area equation to find A, which is negative 1, and B, which is 26. And we can use this information to find the vertex. Okay, so essentially all this problem is asking us to do is find the vertex. So first we do negative B over 2A. And we can plug in our B, which is 26, over 2 times our A value, which is negative 1. And this gives us 13, because negative 26 divided by negative 2 is positive 13. Okay? So this is our W. Now, to find the actual area, we need to go ahead and plug in 13 into our area equation. So our area, the largest area we can have, is going to be found now. So negative 13 squared plus 26 times W. This is equal to, well, we have that negative sign out there. That stays, and then we do 13 squared. 13 squared is 13 times 13, which is 169. Okay. And then I forgot to plug in 13 for W here. I just wrote W, so let me fix that. 26 times 13 is 338. So if we add negative 69 plus 338, then we get a positive 169 feet squared as our answer. So here is our answer, and I'm going to box it in green. Okay, so the largest area that the garden can be is 169 feet squared. Okay, so let me walk you through the steps here. The first step is to go ahead and annotate your word problem. Once you do that, then you can label your diagram with length times width. Okay, then you want to write out this perimeter formula, and then plug in the value that they give you, 52. And here you're going to solve all the way down until you can solve for L. Once you solve for L, the third step is to write out your area formula. Okay, you want to substitute in your L equation that you found in step 2, and then you want to simplify by distributing to find your value of A. Okay, once you find your area equation, you need to identify A and B, and then you can plug those in to ultimately find the vertex, which is what the problem is asking us to solve. Okay, so for your vertex, first you have to do negative b over 2a. So this is the fourth step. And then you plug in your value of w, which is 13, into the area formula, and then you'll have your largest area. Okay? So I want you to try the same techniques on this problem here. Okay? I'm going to provide you with the final area, and then I want you to see if you can get to that answer. If you have problems getting to that answer, just send me an email and I can help you. So your area should be 121 inches squared. Okay, so don't forget to find your area. Okay, your perimeter equation is 2L plus 2W. Remember that your perimeter value this time is 44. Okay, and then so this is step 1. So step 1 I kind of did for you. It's asking us for the largest again. So step 1, I need you to label this. I can do that for you. Go ahead and find your perimeter. Once you solve for L, you should get an equation for L. That's what you're going to end up with. You're going to plug that in over here in step 3 and find your area formula. And then step 4, you're going to find your vertex. So you're going to use negative b over 2a. Find that, and then plug that value back into your area formula. Okay? Adding x. So here is an example when we have to actually add x to our diagram in order to help us write our quadratic formula. So a garden measuring 12 meters by 16 meters is to have a pedestrian pathway installed all around it, increasing the total area to 285 square meters. What will be the width of the pathway? So here what we need to do is go ahead and label the diagram given. So our diagram tells us only information about this inner rectangle. So we have two rectangles here. And since I'm increasing the area, at first I start off with the rectangle that's inside, the smaller one that I'm outlining in red. That's what I have now. The one that I'm outlining in black, this rectangle out here, is the new one that I hope to reach later. So the 12 by 16 is telling me about that red rectangle. So what I have is that it's 12 in length and it's 16 meters in width. Okay. Now, when I increase my area, that's what this black rectangle is. That's where I'm trying to go. So I have to I don't have specific information about it. So the only thing that I can label it with is that it is some value x that I don't know yet all around. So this over here is just some x value that I have to solve for. Okay, so that's how you label this type of problem, where you start with measurements and it says that you want to increase the area. Then you'll have to label it just as so. Okay, so when you have your practice problem, you want to label, so I can flick to that really quickly. In your practice problem, you would label the inner rectangle with 8 by 10, and then this outer one you would have to label with X's all around, and I'll let you fill in the rest when you get here. Okay. So now we can write our formula. So we have to take the area first because area equals length times width, correct? And we'll write that out. So our area is 285 equals our length. Okay, so our length is going to be 12 plus the other lengths. So I have this x and this x. Well, if I add both of those x's together, I'm going to get 2x. So our length is going to be 12 plus 2x. Now with our width is 16. Okay. And our other width is x, and then we have another x here. So we add those together. Well, 16 I can't combine with the two x's. So I'm just going to have 16, but I can combine the two with x's. X plus x is 2x, and that's how that goes here. So now I can use the distributive property, or I can use the box method to multiply these out. But I'm going to have 285 equals 192 plus 24x plus 32x plus 4x squared. Okay, that's what, when I multiply these two binomials together, I get these 4 terms. Now I can simplify by combining like terms, which is going to be 24x and 32x. So 285 equals 192. And let's write it in standard form actually. So we'll have 4x squared first, plus 24x plus 32x is 56x, plus 192. Now I need to get this in standard form, so I need to have 0 on one side of the equal sign. So I'm going to subtract 285 from both sides. Okay, so my final quadratic is 0 equals 4x squared plus 56x minus 93. Okay, so in this case, A is 4, B is 56, and C is negative 93. So I need to solve because it's asking me what the width will be. So I need to actually plug A, B, and C into the quadratic formula. So we're going to start up here. W equals negative B. We'll fill this in later. Plus or minus the square root of B squared. Oh, didn't mean to write B. Of B squared minus 4AC all over 2A. All right, let's plug it in. So B is 56. 4 times A is 4, times C is negative 93. Okay, and then A is 4. So let's simplify. Negative 56 plus or minus the square root of 3136 plus 1488 all over 2. And this equals negative 56 plus or minus the square root of 4,624 all over 2. And now we can write our two equations, which is what this plus or minus sign means. So our first equation is going to be negative 56 plus 68 divided by 2. Where did that 68 come from? So if you put in the square root of 4,624 in your calculator, you'll get 68. That's where that came from. And then so negative 56 plus 68 divided by 8 is 1.5. And then negative 56 minus 68 divided by 2 is equal to negative 15.5. Okay, so we have to decide which of these width values we can use because they're both W. Well, remember we can only use the positive value. So our answer here is 1.5 because 15.5 is negative. Okay, so what will be the width of the pathway? The width of the pathway is 1.5 meters wide. Great job. Okay, so you can go ahead and try this problem on your own. I can help you label your graph and, excuse me, not your graph, your diagram, and you can do the rest. So this is 8, this is 10, and these are all x's. Okay, use the same steps from before, and your final answer should be 2 inches wide. Email me if you have questions about this. What about minimums? Okay, so we were talking about largest in our last 2 example problems. When we're talking about minimums, so your factory produces lemon-scented widgets. You know that each unit is cheaper the more you produce. But you also know that cost will eventually go up if you make too many widgets due to the cost of storage of the overstock. The guy in accounting says that your cost for producing X thousands of units a day can be approximated by the formula C equals 0.04 x squared minus 8.504x plus 25,302. Find the daily production level that will minimize your cost. So let's go through and identify the important components. Of course, this equation has to be rather important for us. And also what it's asking us to do. It's saying to find the daily production level that will minimize your cost. So it doesn't say largest anymore. We're talking about minimums. So if we have a minimum, that means we have an upward shaping parabola, and our vertex would be called the minimum in this case. Okay, so all we have to do is find the minimum of our cost. So that means the only thing we need to find is our vertex. Okay, so we know that A is 0.04, B is negative 8.504, and C is 25,302. Okay, and this all came from this C formula here. So my width value of my vertex, or my x value, because that is the variable that's used in our C equation, I'll use it here too. We have negative b over 2a, so negative 8.504 over 2 times 0.04, and this gives us 106.3. Okay, so that's the x value of our vertex. Remember, vertex is a point that needs an x and a y value. So to find that y value, or in this case is C, we plug in 106.3 into our original equation. So we should have 0.04 times 106.3 minus 8.504 times 106.3 plus 25,302. Okay, and when we plug this all in, we'll get actually, let me just make this easier on yourself. So it's only asking us to find the level that will minimize our cost. So we really only need to solve for x, because x represents, like it says here, the thousands of units a day. Okay, So we want to know how many units a day, and that's represented by X. So we don't need to plug it in any further. We do need to keep in mind that it represents thousands. So if we produce 106,300 widgets per day, we will minimize cost. Well done, scholars. All right, you have reached the end of your very last algebra assignment for the 2019-2020 school year, if you have a 70, that is. So congratulations to you. Fantastic. You're awesome. You're great, and I'm very proud of you. Your last thing to do is to complete the More Applications IP that you can find on Haiku for today, which is the date of 5/20 and 5/21, okay, on Haiku. And don't forget that the bonus project is due Friday by midnight if you have not already done it. All right, later, y'all. Have a great summer. Unless you're taking algebra this summer too, I'll see you then. Otherwise, enjoy your summer.